Welcome back, students. In the last session, we learnt about the conservation of momentum, its derivation and its applications. Now, in this session, we will be covering up the numerical problems based on the conservation of momentum, that is based on the equation MAUA plus MBUB is equal to MAVA plus MBUB. So, we will be using this equation to find the answer for the numerical problems. It is momentum before collision and momentum after collision are the same. Using that concept, we will be solving numerical problems. So, let us pass on to the questions. So, for the questions, you may please refer your NCERT science textbook. First question is page number 124, example 9.6. Page 124, example 9.6, and the question is: a bullet of mass 20 gram is horizontally fired with a velocity of 150 meter per second from a pistol of mass 2 kilogram. What is the recoil velocity of the pistol? So, this is a question. So, let us write the given quantities first. A bullet of mass 20 gram. So, mass of bullet is given as 20 gram. Again, here mass is given in the unit gram, but we know the SI unit of mass is kilogram. So, we need to convert grams into kilograms. For that, to convert gram into kilogram, let us divide it by 1000. So, unit changes to kilogram. 20 by 1000 is 0.02 kilogram. So, we change the mass of bullet into the unit kilogram. It is equal to 0.02 kilogram. So, that bullet is horizontally fired with a velocity of 150 meter per second. So, velocity of the bullet is 150 meter per second from a pistol of mass 2 kilogram. So, bullet is fired from a pistol of mass 2 kilogram. So, mass of pistol is 2 kilogram. What is the recoil velocity of the pistol? So, you need to find the velocity of the pistol. Again, initially when it was not fired, when the bullet was not fired, the pistol and the bullet was at rest. So, we can write initial velocity of both pistol and bullet was 0 before we fired. So, before firing, the bullet and the pistol was at rest. So, their initial velocity is equal to 0 meter per second. So much is given in the question. We need to find the recoil velocity of the pistol. So, the equation that we use is MAUA plus MB. The equation to be used is MAUA plus MBUB is equal to MAVA plus MBVB, where A and B are the two objects. So, here we have bullet and pistol as the object. So, that is, let us replace the equation, that is M of bullet, U of bullet plus second object is pistol. So, mass of pistol by initial velocity of pistol is equal to, again, mass of bullet into velocity of bullet plus mass of pistol into velocity of pistol. We just rewrote it into the terms of B and P, that is bullet and pistol, that is it. We just rewrote it reroute the equation in terms of bullet and pistol. That is it. No other changes. Okay. So, this is the equation. Now, the question is to find velocity of pistol. So, let us make some rearrangements in the equation. MBUB, or let us substitute the values. What is MB? Mass of bullet. Mass of bullet is 0.02 kilogram. So, mass of bullet is 0.02 into UB. Initial velocity of bullet is 0. Plus MP, mass of pistol. Mass of pistol is 2 kilogram. So, 2 into, again initial velocity of pistol is again 0 because pistol and bullet was at rest before firing, equal to MB, mass of bullet is 0.02 into VB, velocity of the bullet, velocity with which the bullet moved is 150 meter per second. So, VB is 150 plus mass of pistol is 2 into VP. VP is what we need to find. So, 0.02 into 0, it is 0 plus 2 into 0, again 0. So, the whole left hand side turned into 0. The answer of the whole left hand side is 0 is equal to 0.02 into 150 plus 2 VP. Now, take this 0.02 into 150 to the other side. So, it becomes, or solve 0.02 into 150. When you solve 0.02 into 150, you will get the answer as 3 plus 2 VP. 0.02 into 150 is 3. So, it is 3 plus 2 VP. Again, take this 3 to the other side. So, it becomes minus 3. You are taking this positive 3 to the other side. So, it becomes minus 3 is equal to 2 VP, or VP is equal to minus 3. Taking this 2 to the other side becomes divided by 2. That is VP is minus 3 by 2. When you solve it, you will get the answer as minus 1.5 meter per second. So, you got the velocity as minus 1.5 meter per second. Again, in the answer, we have a negative sign. What does it indicate? What does this negative sign indicate? The negative sign shows that the motion of bullet and the motion of the pistol are in opposite direction. The motion of bullet is forward and the recoiling of pistol is in the backward direction. So, to show that opposing direction, we have a negative sign in the answer. So, answer is VP is equal to minus 1.5 meter per second. Now, let us pass on to the next question. That is page number 125, example 9.7. Page number 125, example 9.7. Question is, a girl of mass 40 kilogram jumped with a horizontal velocity of 5 meter per second onto a stationary cart. The mass of the cart is 3 kilogram. What is her velocity as the cart starts moving? Okay, this is a question. So, let us write the given quantities first to do the numerical problem. A girl of mass 40 kilogram. So, the first object is girl and the mass of the girl is represented using the letter mg. Mass of the girl is 40 kilogram. Jumps with a horizontal velocity of 5 meter per second. So, a girl is jumping with a velocity of 5 meter per second onto a stationary cart. So, the cart is stationary. Stationary means the cart is at rest. So, the initial velocity of cart is UC is 0 meter per second because the cart was stationary. The mass of the cart is 3 kilogram. So, mass of the cart is 3 kilogram. What is her velocity as the cart starts moving? So, when the girl jumps onto the cart starts moving, and along with the cart, the girl also moves. So, what is her velocity? What is her final velocity? So, here a girl is jumping onto a stationary cart. So, initially the cart was at rest. So, when the girl jumps onto the cart, due to her force, the cart starts moving and the girl is on the top of the cart. The girl is on the top of the cart. So, along with the cart, the girl also moves. And since the girl is on the cart, the velocity of the cart and the velocity with which the girl moves will be the same because the girl is on the cart. The girl is on the cart. So, the velocity with which girl moves and the velocity with which cart moves will be the same. So, after collision, Vg and Vc will be the same, which is, let us equate it to V. Let the common velocity be V. And we need to find the value of this V. We need to find the value of this V. Okay, that is a question. So, the equation that we know, that is the equation of conservation of momentum is MAUA plus MBUB is equal to MAVA plus MBVB. So, here instead of the first object A, we have the girl. So, the second object B, we have cart. So, let us rewrite the equation in terms of girl and cart. So, MA, MG, UG of that of the girl plus MC, UC, the momentum of the cart is equal to MG, VG, momentum of the girl after collision plus MC, VC, momentum of the cart after collision. We just rewrote the equation into the terms of girl and the cart. Now, as we told earlier, the velocity of the girl and velocity of the cart, the velocity of the girl and velocity of the cart are the same after collision because since the girl is on the top of the cart, the girl and the cart will move with the same velocity V. So, after collision, the girl and the cart are moving with the same velocity V. So, instead of Vg, let us substitute V, and instead of Vc also let us substitute V, since both are moving with same velocity after collision. Again, MgUg plus MCUC is equal to, in both the terms we have a common velocity. So, let us take it outside. So, V into Mg plus MC. Now, let us substitute the values. Mg, mass of the girl. Mass of the girl is 40 kilogram. So, 40 into Ug. The velocity with which the girl moved is 5 meter per second. The velocity with which the girl moved is 5 meter per second. So, 40 into 5 plus mass of the cart. Mass of the cart is 3 kilogram. So, mass of the cart is 3, and initially the cart was stationary. So initial velocity of the cart is 0 equal to V into, again mass of the girl is 40 and mass of the cart is 3. 40 plus 3. Now 40 into 5, 200 plus 3 into 0 is 0. 3 into 0 is 0. So plus 0 is equal to V into 43. Now to solve V is 200, here it was into 43. So when it go to the other side, onto the left hand side becomes division. So V is 200 by 43, and when you solve it, you will get the answer as 4.65 meter per second. So velocity of both girl and cart after collision V is 4.65 meter per second. Now moving on to the next question, that is there in page number 126. Page number 126, example 9.8. Page number 126, example 9.8. Question is, two hockey players of opposite teams, while trying to hit a hockey ball on the ground, collide and immediately become entangled. Entangled means they became as one object. One has a mass of 60 kilogram and was moving with a velocity 5 meter per second, while the other has a mass of 55 kilogram and was moving faster with a velocity of 6 meter per second towards the first player. In which direction and with what velocity will they move after they become entangled? Okay. So two hockey players of opposite team, they are trying to hit a hockey ball and they get collide and become entangled. One of the hockey players having a mass of 60 kilogram. So mass of the first hockey player is 60 kilogram and he was moving with a velocity 5 meter per second. So he was initially moving with a velocity of 5 meter per second. While the other has a mass of 55 kilogram. So second player is having a mass of 55 kilogram and he is moving faster with a velocity 6 meter per second towards the first player. So if this is the first player of mass MA, he is moving with the velocity 5 meter per second, and a second player of mass MB is moving towards the first player with velocity 6 meter per second. So he is moving towards the first player, that is in the opposite direction. So here the second player is moving with the velocity 6 meter per second towards the first player. That is, the movement of second player is opposite to that of first player. To show the opposite motion, we should put a negative sign in the velocity, because here if the first player is moving towards the right side, second player is moving towards the left. Both are having opposite direction motion. To show that opposite direction, we put a negative sign in one of the velocity. So since the second player is moving towards the first player, the direction of velocity are opposite. To show that opposite velocity direction, we put a negative sign. With what velocity will they move after they become entangled? So the question is to find, so after collision they becomes entangled. So velocity of the first hockey player and velocity of the second hockey player will be the same, which is equal to v, and we need to find this v, common velocity. So, after collision they become entangled and they move as one single object. After collision they become entangled and they move as one single object, and we need to find the velocity of that entangled object, the common velocity of that entangled object. That is the question. So, equation is MAUA plus MBUB is equal to MAVA plus MBVB. Now, let us substitute the values. Mass of the first hockey player is 60 kilogram and he was moving with a velocity 5 meter per second. So, 60 into 5 plus MB, mass of the second player. Mass of the second player is 55 kilogram and he was moving with a velocity minus 6. So, 55 into minus 6 is equal to MA is 60 into VA. After collision, both the players are moving with velocity V. So, instead of VA, let us substitute V plus MB is 55. Again, after collision, they becomes entangled and they move with the same velocity V. So, VB is also equal to V. Now, 60 into 5, that is 300 plus 55 into 6, it is 55 into minus 6, it is 330 is equal to 60V plus 55V. 300 plus minus 30, that is 300 plus into minus, it is minus 330 plus into minus, it becomes minus 330 equal to, in both the terms we have V common. Let us take outside, so it becomes V into 60 plus 55. 300 minus 330, it is minus 30 equal to V into 60 plus 55, it is 115. So, it becomes, V becomes minus 30, V into 115. So, when we take that 115 to the left hand side, it becomes divided by 115. So, V becomes, V is equal to minus 30 by 115, which is equal to minus 0.26 meter per second. And this is the velocity of the hockey players after collision when they get entangled. After getting entangled, both the hockey players will move with the velocity negative 0.26 meter per second. Now, the next question, let us pass on to the next question, that is there in page number 127. Page number 127, question number 4. By the end of that topic, there are a set of blue questions. In those questions, question number 4. We are doing question number 4 among those questions. Okay. And the question is, two objects of mass is 100 gram and 200 gram. So, we have two objects of mass 100 gram and 200 gram. So, mass of the first object is 100 gram. Again, in the question, mass is given in the unit gram. And we know that SI unit of mass is kilogram. So, we need to convert gram into kilogram. To convert it, To convert gram into kilogram, let us divide it by 1000. So 100 by 1000 kilogram. So answer is 0.1 kilogram. And mass of the second object is 200 gram. Mass of the second object is 200 gram. Again we need to convert gram into kilogram. For that, let us divide it by 1000 to change the unit gram into kilogram. It becomes 0.2 kilogram. Let us come back to the question. Two objects of mass 100 gram and 200 gram are moving along the same line and direction with velocities 2 meter per second and 1 meter per second. So, they were moving initially with velocities 2 meter per second and 1 meter per second. With velocities 2 meter per second and 1 meter per second. They collide, and after collision, the first object moves at a velocity of 1.67 meter per second. So, both gets collide, and after collision, the first object is moving with a velocity 1.67 meter per second. 1.67 meter per second. Determine the velocity of the second object. We need to find what is V2. That is the velocity of the second object after collision. So, these are the quantities that is given in the question, and we need to find the velocity of the second object after collision. Again, the equation used is MAUA plus MBUB is equal to MAVA plus MBVB. Now, let us substitute the values of all the quantities in the equation. Mass of the first object is 0.1 kilogram and it was moving with a velocity 2 meter per second. So, M is 0.2 into MA is 0.1 into, it was moving with a velocity 2 meter per second. So, UA is 2 plus mass of the second object is 0.2 and it is moving with a velocity 1 meter per second. So, 0.2 into 1 is equal to mass of the first object is 0.1. After collision, the first object moved with a velocity 1.67 meter per second. So, VA is 1.67. Mass of second object MB is 0.2 into velocity of the second object. That is what we need to find. That is what we need to find. We need to find velocity of the second object VB. Now, 0.1 into 2 is 0.2 plus 0.2 into 1, again 0.2 is equal to 0.1 into 1.67, it is 0.167 plus 0.2 into VB is 0.2 VB. Now, 0.2 plus 0.2 point. Now, we need to find VB. So, take this 0.167 to the other side. So, 0.2 plus 0.2 is 0.4 equal to 0.167 plus 0.2 VB. So, we need to solve this VB. So, over here we already have 0.4. Now, take this 0.167 to the left hand side. It becomes minus 0.167 is equal to 0.2 VB. Again, we need to solve for VB. Now, we need to take this 0.2 to the other side. So, it becomes 0.4 minus 0.167 It was 0.2 into VB. Now we are taking this 0.2 to the left hand side. So it becomes divided by 0.2. So 0.4 minus 0.167 divided by 0.2. And when you subtract and divide and solve this, you will get the answer as, when you solve this, you will get the answer as VB. When you solve this left hand side part, you will get the velocity of the second object as 1.16 meter per second. Subtract it and then divide, and then you will get the answer as 1.16 meter per second. It's a direct question using the equation MAUA plus MBUB is equal to MAVA plus MBVB. Hope it is clear for everyone. Please make sure that just after the session, please write and learn all the problems. Thank you.